Bitwise operators, this is one of the interesting topic. These operations are performed on the bits of the data, not on the whole data as a single unit, but on the bits of the data. Let us see what are the operations available. See, bitwise AND, bitwise OR, and bitwise XOR or XOR, and bitwise NOT, left shift and right shift. Let me quickly show you how these operations work. See, if there are two bits, bit 1 and bit 2, two bits are there, and if both the bits are 0, then bit 1 and bit 2 will also be 0. And if any one of the bit is 1, then also it is 0. If this is 0, this is 1, then also 0. And if both are 1, then only it is 1. So it is just like a logical AND. So when you use bitwise ANDing, it will be 1 if both the bits are 1. Then if I say OR, then this will be 1 if any one of the bit is 1. See, this is 1, so answer is 1. Out of these two bits, this is 1, so answer is 1. Or both are 1, so the answer is 1. Then if it is XOR, this one, then if both the bits are different, then only it will be 1. Both the bits are same, then it will be 0. Exclusive OR means exclusively, if one is a 1, then the other bit must be 0. Or if one bit is 0, then the other bit must be definitely 1. So this is XOR. NOT means whatever the bit is there, if it is 1, it will become 0. If it is 0, it will become 1. Then this. Let us learn all these operations by using examples. While explaining that, I'll also explain about the shift operations. If I have integer variable x and the value is 11 and the y value is 5. Now, these two integer variables I have taken, we know that these numbers are actually stored in the binary form. So what will be the value of x in the binary form? 11 means 1011. If I say integer takes 2 bytes, then it will be total 16 bits. So 4 bits are there, then the remaining all bits will be 0 only. But I will not write all 16 bits, I'll just write 8 bits here. Then same way, y value 5, it is 101. And the remaining bits are all zeros. So let us understand this upon 8 bits only. And if I use AND operation now and try to store the result in one more variable z, let us see what happens. If I say z assign x and y, then these bits are AND. 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 1 and 0 is also 0. So this will be 1. So binary form, it is 1. So z will get the value 1. So this is how bitwise ANDing is performed. So if you AND 11 and 5, then the result is 1. I'll change the value. Instead of 5, I will take 7. Let us see what will be the result. 7 is 111. Then what will be the result? 1 and 1, 1. 1 and 1, 1. 0 and 1, 0. 1 and 0, 0. And all these are zeros only. Then this is how much. In binary form, this is 1, 1. So in decimal form, it will be 3. So 11 and 7, result is 3. Let us see what will be the result of OR operation. So I will take x as 11 only and y as 7. Then instead of AND, I will use OR operation. Then result will be 1 or 1 is 1, 1 or 1 is 1, 0 or 1 is also 1, 1 or 0 is also 1, and all these are zeros only. Then this is in the binary form, it is 1111. So in decimal, it is 15. 11 or 7 is 15. See, it is not like addition or subtraction. Directly you look at the value and give the answer. Unless you perform some bitwise operations, you cannot give the answer. If you have some practice on this one, then you may be able to directly give the answer by looking at them. Now next, let us see what is the result of XOR. This XOR operation I will take. both are same 0, both are same 0, these two are different 1, these two are different 1, then leading all are zeros. So this is 12. Result is 12. In decimal form, this is 12. See, this is 1, 2, 4, 8. 8 plus 4 is 12. So the answer is 12 here. Let us look at not. I will take a character type variable x with value 5 and also one variable y. Character takes just one byte in C++. So this x in the binary form, it will be 5 is 1, 0, 1. And remaining all bits are zeros. So this is the binary form of 5. Then if I say y assign not of x, then let us see what happens. Not means every binary bit will change its state. That is 0 will become 1, 1 will become 0. So this becomes a 0 and 1 and 0. Then all these are ones. So this is the complement or the not of x. Now as this bit is a sign bit, so this is 1 now. So it means the number is negative. The negative numbers in C++ are represented in 2's complement form. If you want to get the positive value of it, then again you have to take 2's complement, then you get the positive value. So it is a negative number. Then what is the value in decimal form? So to know the value in decimal form, I should convert it into 2's complement, then I can get the value. So let us convert into 2's complement. First convert zeros to ones and ones to 0. So this is 0, 0, 0, 0, 0, 1, 0, 1. Then add 1 to this number. So 1 plus 1 is 2, that is 0 carry 1, and this is 1 and this is 1. Then 0, 0, 0, 0, 0. Then how much this is? 6. So this is a negative 6. So not of 5 is minus 6. Now before going further, let us put a question here. Where do you need this? If you are developing device drivers, or if you are developing core system programs or system applications or tools, then there you may be working more closer to electronics, and these are the operations in electronics. So your C program also, you want it to perform those type of operations. Your logic itself is defined in terms of bit operations, so then you can use this operators there for writing your procedures. So if you are writing hardware based or device drivers, there it is useful. Now let me show what does it mean by left shift and right shift. I will take the value of x as 5 and y. So in binary form, 5 is 1, 0, 1. So leading all 16 bits as zeros, remaining bits are zeros. So I will just add 8 here. I will write just 8 bits here. This is x. Left shift by 1, and I want to store the result in y. Then this bit is shifted here. So this is 1 and this is shifted here 0. This is shifted here 1, and all these bits are shifted this side. So remaining 5 bits are shifted this side. This place is vacant now, so here 0 is inserted. Now how much this is? This is 1, 2, 4, 8. So this is 8 plus 2. This is 10. So actually what has happened is, when you shift all these bits on the left hand side by one space, then this 5 will get multiplied by 2. If you move them by 2 space, then it will get multiplied by 4. So it is just like whatever the value of x is, this will get multiplied by 2 power whatever the number you write here, whatever the number you write. So if I say x left shift I, then this will be x into 2 power I. So if it is 1, then it is multiplied by 2. If I is 2, then x will be multiplied by 4, and so on. Now similarly, if right shift is used, then if I say x right shift by I, then x will get divided by 2 power I. So if 5 will get half, that is a 2 integer division. If it is a 10, it will become 5. So the number will become half if you right shift by one place. If it is done by 2 place, then it is divided by quarter, that is 4. It will convert into quarter, that is divided by 4. But one thing you remember here, sign bit is not included. The most significant bit, if the number is negative, it remains negative only. If it is positive, it remains positive only. Sign bit is not a disturb in left shift and right shift operations. Let us see this practically by writing some program.